Welcome. This video is EYCN. All right, so today we're going to talk about sum and difference identities. I'm just going to give you the identity. I do show you where all of these identities come from in a separate video called something like identity derivations or something, but it'll be there. Here we go. So we're going to start with a cosine sum and difference. And if you watch the video, you'll see why we start with cosine. So here we go. The cosine of angle A plus angle B is cosine A, cosine B, minus sine A, sine B. And the difference, cosine of A minus B, is similar. Cosine A, cosine B, now plus sine A, sine B. Now I want to make it clear, when it's addition, it becomes subtraction. And when subtraction becomes addition, they're exactly opposites of each other. And again, I show where all that comes from. So I'm going to go to the example here. We have cosine of 3 pi over 7 and cosine 2 pi over 21. And here we have the plus. So we're here using this formula here. So this actually means A in this case. This becomes cosine of 3 pi over 7 minus 2 pi over 21. And now I have to get a common denominator for that. So that's going to be 9 pi over 21 minus 2 pi over 21, which gives us the cosine of 7 pi over 21. And very nicely, this reduces to the cosine of pi over 3. Remember, cosine is the x-coordinate on the unit circle. So here's pi over 3, and the x-coordinate is 1/2. So we can actually get the exact answer by using these identities. Let's try another one. We want to find the exact value. Now, when it says exact, that means no decimals. Okay, that's on a test, that's anywhere. Exact means exact. So I'm going to notice that cosine of 15 degrees is the same as cosine of 45 degrees minus 30 degrees. Well, now we're here. And I'm going to actually use A for 45 and B for 30 degrees. So this becomes the cosine of 45 degrees times the cosine of 30 degrees. And because it's minus here, it's now plus sine of 45 degrees, sine of 30 degrees. And using our unit circle, we can figure out cosine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Plus sine of 45 degrees is here, root 2 over 2. Times sine of 30 degrees. Here's 30 degrees. The sine is 1/2. So this gives us root 6 over 4 plus root 2 over 4. And they already have a common denominator, which is nice. Now, it is possible to factor out a root 2. You can see I could pull a root 2 out at the beginning here. In fact, a root 2 over 4 I could pull out. And we're left with root 3 plus 1. Sometimes some online systems have you write it that way. All right, let's keep going. Find the exact value of cosine of 5 pi over 12. I'm going to split that up to be the cosine of, notice we're in radians now, 2 pi over 12 plus 3 pi over 12. Now, you might be asking yourself, how did I know to break it up that way? Well, it comes with a lot of practice. So you can try breaking up 1 pi over 12 plus 4 pi over 12 and so on until you come up with a combination. I noticed that when I have this reduces very nicely to my unit circle angles in radians, which is nice. So now I'm using the plus formula. So it's going to be cosine pi over 6, cosine pi over 4 minus sine of pi over 6, sine of pi over 4. So we have cosine of pi over 6, cosine pi over 4. And again, because we're plus now, it's now subtract. Sine of pi over 6, sine of pi over 4. And cosine of pi over 6, here's pi over 6, cosine is x, that's root 3 over 2. Cosine of pi over 4, here's pi over 4, cosine is the root 2 over 2. Minus sine of pi over 6. Sine of pi over 6, that's 1/2. Times the sine of pi over 4. Here's pi over 4, sine right there, root 2 over 2. Once again, we could pull out a root 2 over 4, but I'm not going to bother for this one. This gives us root 6 minus root 2 all over 4. And a way that you could check that is we could go here. We could do this with the previous example as well. Now I'm going to make sure I'm in radian mode, which I'm not, because I'm dealing with radians. So if I do cosine of 5 pi divided by 12, I get a decimal. Now when I crank this out, I should get the same decimal out. Let's see. Square root of 6 minus the square root 2 divided by 4. You'll note we get the exact same value. You can test it on the previous example as well. Make sure you're in degree mode. You'll have to switch. All right. So what if we need sine and cosine? Some difference. No problem. And again, I show where all these come from in another video. So this plus here, it's plus here. It's kind of the opposite of cosine. Here we have some difference of sine. I'm going to go ahead and throw down the tangent one as well. So we'll say tangent of a plus b is tangent of a plus the tangent of b over 1 minus tangent a times tangent b. And our subtract one I'll put over here. Tangent of a minus b is equal to the tangent of a minus the tangent b over 1 plus tangent a tangent b. So you'll notice same sign on top, opposite of the bottom. Same sign up top, opposite in the bottom. So let's do an example. Find the exact, and again, it says exact, that means no decimals, of sine of 19 pi over 12. I'm going to break this up into sine of 10 pi over 12 plus 9 pi over 12. Again, that takes quite a bit of practice to figure that out. The reason I knew this was because when I reduce these, 10 pi over 12 reduces to 5 pi over 6, which is in my unit circle. Also, 9 pi over 12 reduces to 3 pi over 4, which is also in my unit circle. So now I'm going to use some angles for sine. A in this case is the 5 pi over 6. B in this case is the 3 pi over 4 up here. That's plus cosine of 5 pi over 6 sine 3 pi over 4. All right, so let's grab our unit circle again. 5 pi over 6 over here. Sine is the y value, so that's going to be a positive 1/2. Cosine of 3 pi over 4, 3 pi over 4 is here. Cosine is the x, that's a negative root 2 over 2. Cosine of 5 pi over 6, 5 pi over 6 is here. Cosine is the x, that's negative root 3 over 2. And sine of 3 pi over 4, 3 pi over 4, sine is the y-coordinate, it's a positive root 2 over 2. This looks like negative root 2 over 4 minus root 6 over 4. So here would be the exact value. Now you could factor out and bring it front. You could factor out a negative root 2 and so on to make it look slightly different. But this is, again, the exact value. And you'll notice it's negative. Overall, this is going to be a negative number. And I do want to point out that sine of 19 pi over 12 is in quadrant 3. So it is appropriate that sine is going to be a negative value in this case. All right, next up, we have of x plus y minus sine of x minus y. And we are looking for whatever this function is going to be. So sine of x plus y I have up here. That's sine of x, cosine y, plus cosine x, sine y, minus, now I have this one here, where a is x and b is y. So we have, and I'm going to be extra careful with the minus. So we have sine of a, cosine of b, minus cosine a, sine b. And what I'm going to need to do is distribute the negative here. And I'm going to very quickly notice that, oh, I switched to A and B and I need to stick to X and Y. So x and y, x and y, x and y, x and y. So very nicely, what we get, these completely reduce out. And you'll note these are the same. Again, that's x and y. So I have two of them. So I'm just going to combine up my like terms. So this gives me 2 cosine x sine y. So when we're looking for f of x here, what is that function of x? It's right there. We can see it. So f of x, in this case, is the cosine of x. All right. Next up. So we have that the sine of alpha in quadrant 2 is 12 over 13. Now we're in quadrant 2. That means cosine of alpha is going to be negative. And I'm going to quickly set up a triangle here for alpha. Sine is 12. The hypotenuse is 13. And when I do the Pythagorean theorem, this is x squared plus 12 squared equals 13 squared. And that is going to give us x squared equals 25, which means that x is -5. Remember, we're in quadrant 2. -5, which means cosine of alpha is the adjacent, which is -5 over 13. We'll do something similar. Beta. Sine is the opposite. Beta is in quadrant 1, so both sine and cosine are both positive in quadrant 1. So that's going to be 3, that's going to be 5. That's going to be x again, so x squared 3 squared equals 5 squared. Now, again, we can do the plus or minus, but because we're in quadrant 1, x in this case is going to be a +4, which means the cosine of beta is 4 over 5, adjacent over the hypotenuse. All right, what does that mean for us? Well, that means when we find sine of alpha plus beta, sine of alpha plus beta gives us sine of alpha cosine of beta plus cosine of alpha sine of beta. Spread that out a little bit. So sine of alpha we have, that's 12 over 13. Cosine of beta we have here, times 4 over 5. Plus cosine of alpha I have here, that's -5 over 13. And sine of beta is here, that's 3 over 5. So that gives us 48 over 13 times 5. I think that's 65. 13 times 5, 65. Minus 15 over 65. That's going to give us 33 over 65. There is our exact value. Cool stuff. All right, so we're going to use our sum in this case. So the tangent of 75 degrees is going to be the tangent of 45 degrees plus 30 degrees. So we're back to degrees. And this is going to give us, looking at our formula sheet, or in this case, A and B are 45 degrees and 30 degrees. So remember, it's plus on top, minus down below. So tangent 45 degrees. So tangent 30 degrees divided by 1 minus tangent of 45 degrees, tangent of 30 degrees. So using my unit circle, 45 degrees, that's here. Tangent is 1. Tangent of 30 degrees, that's here. That's root 3 over 3. Down below, I have 1 minus. Tangent of 45, we just saw was 1. Tangent of 30 is root 3 over 3. And what I'm going to do to simplify this just a little bit better is I'm going to multiply the top and bottom both by 3. Get rid of that complex fraction there. So this gives us 3 plus root 3 over 3 minus root 3. And once again, we can verify that. I'm going to be in degree mode. So if I do the tangent of 75 degrees, tangent of 75, I get a funky number. And now I'm going to put this in. I'm going to use parentheses. 3 plus the square root of 3, parenthesis, divided by parenthesis, 3 minus root 3. You can see we get the same number. But ours is exact, which is much better for us mathematicians. All right, last problem for the video. Use an addition or subtraction formula to write the expression as a trigonometric function of one number. Well, I'm going to notice that I have minus in between, and the minus in between means that I'm going to take a minus b. So this is going to become the tangent of a, which is 72 degrees, minus 12 degrees, which is our b. And it looks like this is tangent of 60 degrees. And tangent of 60 degrees, that's up here, tangent is root 3. I know these can be a little confusing. And once again, if you want to know where these formulas come from, check out the other video.